Hello everybody, John Vincent back with you, and now we're going to take a look at NXCam Post Configurator. In the past, we've already covered some topics about the difference between Post Builder and Post Configurator, and so now we're going to take a little step into some more detailed topics, more advanced topics. So we're going to do a couple things. We're going to look at multi-chain posts and how they can be used. Typically, I think about this as using multiple chains instead of multiple linked posts. We're going to discuss user interface objects and properties and how they apply, and also how we can collect UDE data with using the pre-treatment functions inside of Post Configurator to go ahead and have data available to us earlier in the post run. Alright, so the first thing we're going to do is look at creating a multi-chain post. So in this scenario, we're going to kind of have a practice run at creating a post for a mill turn machine. And we're going to show about some of the advantages of Post Configurator, some of the out-of-the-box advantages with Post Configurator in creating post processors for multi-function machines like this that we can handle milling and turning, but also how we can utilize chains within a post to differentiate more settings between, in this example, the milling output and the turning output of a post processor. So I'm going to go ahead and jump right into NX to do some demonstrations here. So in this case, I just have a sample part. I have some milling ops and turning ops available. And I'm going to start by creating a new post processor. So of course, Post Configurator is embedded directly inside of NX, whereas Post Builder was a standalone application. I'm going to go ahead and just specify the folder that I want to add these files to. And I'm going to name my post, let's say NXU virtual mill turn. And I'm going to use a FANUC-based control. And I'll accept take the default manufacturer machine level. Alright, let's go ahead and say OK. And we're going to get our post processor initialized for using the FANUC-based template. So okay, a couple things that we want to do, typical things that I'll do when I'm starting any post. I'll jump down into my kinematic settings and specify my real machine kinematics. This is where I'm really going to specify what is my machine that I'm working with. So in this case, I'm going to specify my machine mode. And this is a mill turn machine that I'm working with. In this case, we have X, Y, Z axes, and a B and a C axis. So we'll leave our machine type set to 5-axis head table. I am going to change the 4th axis vector. Default when you do a head table machine is to have the head at a 45-degree angle. Ours is not. It just rotates directly around the Y axis. And C axis, that should all be good, just rotating around Z. Alright, so let's go ahead and save this post. And simply by setting the fact that this is a mill turn machine, we are going to be able to support output for turning operations and milling operations. So let's just take a quick peek at that. I'll post process right from within Post Configurator this initial facing operation. And my listing window is on my other monitor. Let me go ahead and bring that over. And here we can see that we kind of have our standard turning format. We're specifying an RPM, or constant surface speed in this case. Right here it's an RPM, then it becomes a constant surface speed. G92, we're capping our RPM, working the G18 typical lathe output. By the same token, if I pick a milling operation and post it out, again, we'll see, let me scroll up to the top here, standard milling type output. In this case, 5-axis machine, so we're using our G68.2 plane rotation cycles, again working in G17 plane, standard milling format. All right, so that's working. That's great. But we need to start differentiating. There's going to be different codes for turning versus milling, things like that. So we need to understand how to start differentiating these things. And this is where using multiple chains is going to come into play. So I'm going to start by adding my own custom layer. So in the Layer Manager, I'll go ahead and add a layer directly under the Machine Tool Builder library. And I'll call this my mill turn layer. Get rid of those couple extra spaces there. And I'll create a new directory. I don't need a definition file. All I really want is a TCL file that I can edit right now. So I'll go ahead and say OK. And now I'll have the ability to edit this TCL file that was just created. So you can, of course, review documentation and some training materials to start learning some of the different commands. But it's important to know that the text editor inside of Post Configurator is pretty intelligent. I can start typing some commands, and you'll see that the list is going to populate with possible options that I may want. And in this case, I want to use this command to add a chain. And we can see I get a tooltip flyout here, helping me understand the different parameters that need to be satisfied here, sequencing, things like that. So I'm going to add my chain, and I'm going to name it. Actually, I'm just going to kind of copy and paste here, just for sake of time. What I'm going to name it, how I'm going to classify this. Actually, I missed one of my parameters. Let me go ahead and copy and paste in here. All right, so I know that this is going to add a new chain, a mill spindle turn chain. So let me go ahead and say OK, and we'll see the UI is going to update here in a moment. So two things. We have a mill spindle turn tab at the top, and we now have a chain selection node. This is an object parameter here. And we can see that out of the box, we have some different priorities, conditional values. So there's a number of things that we can look at for mapping. How do we want to automatically select our different chains? So out of the box, there's some options here looking at channel IDs, your main MCS values, MOM machine modes, MOM carrier names. Again, this is all going to depend on what your machine tool is and how you want to make these decisions of what chain to map to. Ours is going to be fairly simple. I want all my default conditions for my normal milling and things like that. The only time I want to use this other chain is when I'm turning. So I'm going to be looking at MOM machine mode. Now I want this, since this is the only parameter I want to look at, I want to change my priorities of these conditions. So again, I'm going to jump back into my TCL file here. And I'm going to come down and inside of this TCL file, I'm going to use some commands to set some different parameters. And this is actually going to be chain priority. And I'll finish up just by copying and pasting the rest of this information in here. So I want to reset my priorities. So first, I want to go by MOM machine mode, then MOM carrier name, channel ID, main, and MCS. And I'll say OK. And we'll see that this dialog is going to close. And when I reopen it, my priorities have been reordered. So all I'm really looking at doing here is saying, anytime my MOM machine mode is turn, I want to use my main spindle turn chain. Alright, so now I've specified my mapping conditions here. Alright, so let's have some different settings on our main spindle turn. If I go ahead and migrate to this tab, you'll see there's no content other than my chain mapping rules. So I want to start inheriting some settings into this chain and make them unique from the default settings. So again, here on the default tab, let's go to our G and M codes, and we'll look at M codes, and we'll look at spindle direction, clockwise, counterclockwise, and off. M3, M4, M5 is the typical format. But I want to add these values, these parameters to my turning chain, and these are actually going to be unique. So M3, M4, M5, that's the commands for the milling spindle. Now for my turning spindle, these are going to be M203 and M204, M205. So real simply, I can edit in the user interface here these different commands. Likewise, maybe I want to change some from diametral mode to radial, or vice versa, actually, from radial to diametral. So I'll take my X factor for turning, I'll add that to my turning chain, and I'll change my X factor for turning from radius mode to diameter. And I'll go ahead and save this. And now if I go ahead and post-process this first facing operation, we should see a little bit of difference here. The main things are M204. This was M4 before. Now it's M204 because it's looking at our turning chain. Additionally, if we had looked at these values originally, the X values were about 55 millimeters, and now we're at about 110. So it is outputting in diametral mode. So very quickly, you can start differentiating some settings from your main chain to your auxiliary chain, or in our case, our milling chain versus our turning chain. So that's some introduction to how the chains themselves work in Post Configurator. So the next thing I want to look at and discuss is user interface objects and properties, and how we can really customize these things. So what I want to do is I want to add a pull-down menu to my tool change properties, and I want to be able to select, do I want to output some tool dimension notes in my code or not? So a couple things. I need to create my own property. And then once I have that property created, I have to use the value of that property to do some action or not do an action, whatever the case is. So the first thing I'm going to look at, how do we go ahead and add an object here, or add a property. So again, coming back to Post Configurator, we'll be editing our TCL file again. And the first thing, before I get into that, let's just take a review of our tool change settings. So under general settings, tool change, right now I want to add my own property after tool change in end of program, but before this auto tool change group. So a couple things we have to think about. First of all, I'm going to go ahead and open up my TCL file. And I'm going to start by creating my own object. So again, I'm going to start typing in some commands here. So I'm using command libge create object. And in this case, I'm going to name my object. Oops. Let me go ahead and copy and paste this. There we go. So I'm naming my custom object tool dimension, and I'm specifying what the user interface name is and the tooltip is going to be. And I'm just going to close that. I need to do another thing. I need to specify what my object, what my parameters are going to be. So I'm just going to, again, for the sake of time, paste in some code here. And what I'm doing is setting my ID for my output tool dimensions. I'm specifying what values do I want available in my pull-down list. I simply want a no or yes selection. And those IDs are going to be a 1 or a 0 value. And this data type is just an integer. We have the ability to set some access rights here. This corresponds to licensing. I'm not going to really touch on this right now. And we're just outputting what is going to be available on our dialog and a description for a tooltip. The last thing is specifying where in my user interface do I want this to belong. And this string is pointing to that tool change group. I'll show how I derived that information here in just a moment. First, let's go ahead and just say OK. And we'll see here in just a moment our user interface. Let's go ahead and save that. And we see we get a new value here, new property. Output tool dimensions, and I get my pull down. No or yes. All right, so how did we figure out where to position this command? Well, under our miscellaneous and debugging node, we have a function in here to show element IDs in the user interface. And if I go ahead and set this to on and save my post processor, we're going to see that we get some information on all these different nodes and objects. So in our case, by coming to the tool change group, I'm specifying that I want this to become part of the customer user interface for the tool change group. So it's just appending it to the end of the list, and you can see that these subgroups here are their own groups. So that's how we can dictate where we want these or where we want properties to locate themselves in the interface. I'm going to go ahead and turn that off because it really makes the interface busy here. All right, so now I have my pull down option, but I'm not really doing anything with it yet. So that's kind of my next step. All I want to do is add a note. So in my auto tool change template, I'm going to change and write my own custom procedure. And if this value is set to yes, I want to output a note. And if it's set to no, then I just want to do the tool change. So again, I'm going to add a little snippet of code here. And I'm checking the logic. I'm checking the status of this pull-down menu. If it equals no, then I'm going to say, okay, don't bother about doing this output. And if it equals yes, I will output this note. And this is just doing mom output text, and I'm simply adding a note. Tool diameter is equal to the variable mom tool diameter. And then, of course, executing the tool change here. So let's go ahead and save this and take a look at the result. Again, I have my pull-down menu set to on, and if I come to my floor wall operation and I post this out, we'll see that I now have a note that's being executed directly before my tool change, just letting me know that my tool diameter is 8 millimeters in this case. Now for turning, this note doesn't really make a lot of sense. We don't have a diameter for a turning tool. We will get the actual nose radius of the insert, but that's not what we want here. So all I'm going to do is I'm going to add this output tool dimensions to my turning chain. And for my example, I just want to turn this output tool dimensions set to no for any turning operations. So now we can take a look and post-process this facing operation, and we'll see there is no note because it's a turning operation, but a milling operation is going to have that note of what the diameter of my tool is. And just to verify, we can see there it is for our milling operation. So again, great way that you can start dividing up requirements for the different chains of your post-processor. And the last thing we're going to look at for this lesson or this session is working with the pre-treatment information a little bit. So common scenario in Post Builder is customers want to create a user-defined event to add some information. Setup notes, part information, program information. Doesn't really make a difference what it is. But they want to do that through a user-defined event. But user-defined events are not in PostBuilder are not available before the start of program, or at the start of program. So there was a number of different tricks. Either you could write the information, run your post processor run, close the file, rerun it, and append that information in there. Or we would save information to the actual part file as an attribute. But any of these, you're really having to run your post processor multiple times, and there's a number of downsides to this with either solution. So now with pre-treatment, we're able to do this directly in Post Configurator with one post processor run. Okay, I'm going to save this post and say OK. And I just want to take a look at a user-defined event. I have a custom user-defined event here. Let's go to our start events, attach to the program group, and I have my swoosh header. Just a couple fields here. We'll add a customer name, part name, work center. Yeah, I'll choose the Mazak here, and a couple user fields. Maybe I want to include a little bit of custom information. I'll just say set Z0 to finish phase. Yeah, basic information. Nothing too crazy here. So of course I've created this user-defined event. If I post something out now, I'm not going to get any difference in my output just yet, because let's take a look. Let me just navigate to that post processor real quick. Because I haven't told the post what to do with this user-defined event, or any of the variables that are assigned to it. So again, you don't see any difference. So a couple things. I want to have my header information output directly after my program number. So I want to show a couple things. One, how do we find this information? How do we use that location? How do we enter in some command at that point in the post processor? I'm going to come to another debugging tool inside of Post Configurator, and I'm going to turn on my inspect tool. So the inspect tool will only run when you are actively posting from Post Configurator. So I can leave the setting on, close Post Configurator, and post directly from the ONT as normal, as I would expect, but I'll get some additional information while posting through the Post Configurator interface. So in this case, I'm just going to go ahead and post out this first operation. And two things. I get my normal code in the listing window, and let's bring over my inspect tool. And we can see we can view the information of this post run in three different views. The actual NC output, let me go ahead and expand this. So you can see the NC output, how it breaks down. It'll organize things by operation. We can also see the list of MOM events that are happening, the different events that are triggered. And then we have our buffer events. And buffers are where it's going to let us kind of intervene at different points in the post run and do some different actions. So in this case, I want to look at my program number, and we can see that this event is happening in the MOM start of program, and the action is happening at this particular buffer ID. So what I want to do is I want to insert after this line, after my first line. Let's verify. Yep, that's first line. You can see when I click on the actual block, it's telling me what the buffer tag is. So after my first line, I want to insert my own action, my own logic here. So I'm going to go ahead and copy this to my clipboard. And now when I launch my TCL file, I can paste this buffer edit in place here, and it's gonna the Post Configurator is gonna look at this buffer, and anytime it runs the post, it's gonna find this at this buffer tag. It's gonna insert my actions, whatever I want to do. So essentially, I'm just gonna add a code. I'm gonna name my procedure STS header. And I'll assign a tag to this buffer event. And now I can create my new procedure to do some action. So let me just go ahead and start a new proc. And I'm going to copy the name that I created, STS header. Rename this procedure. And I'm going to do a couple things here. I just want to do some, I'm going to do output text to keep things simple. So let's see here. Mom, output text. And I'm going to start my format. I want to output, kind of hard coded here, just customer name and then some value. But my variable is not available to me yet. So this is where I need to use pre-treatment. So I'm going to use the command libpt for pre-treatment, and the command get header var. And now it's going to, through pre-treatment, it's going to look for this variable, which is STS customer name. This is just the name that I created, or the variable I created when making my user-defined event. And let's put this in brackets. And now let's go ahead and say OK. And I'll save this. And let's just make sure this first step is going to work here. Again, we'll do our facing operation. I'll post this out. And I must have a little bit of an error here. Let's take a look. Sure enough, I'm just missing a quotation at the end there. Alright, let's do a quick check here. And okay, we'll see that our customer name is outputting. So our logic works. It's in the proper location where we want it. If we go back to our buffer events here in the inspect tool, we'll see that when I click on my the program number, the buffer tag first line, it's outputting my buffer tag event here, which is listing my customer name so far. We'll extend that just a little bit further. And I'm just going to, again, copy and paste some text now, just to extend the rest of the fields. And here we have the different values that we're going to output. So we want to output our customer name, part name, work center. And then we also have some additional checks in here that if these user fields are blank, we don't want to output a blank field just saying user field 1 with no content. We only want to output with the information that's actually populated. Alright, so I'll go ahead and say OK, save this post processor. And we'll go ahead and post out the entire program. And here we see once this wraps up the post run, we should see our full header with all the information that was entered inside of our user-defined event, which is customer name, part name, and work center. And we filled out one of these user fields with some basic setup information. So cool way to go ahead and use pre-treatment to access some of these user-defined event informations or data earlier in the post run. A couple of little things before we wrap up this lesson. I just want to make note that Post Hub has been updated a little bit. On the left-hand side of the screen, there's now the home page and a second page called Support Resources. Under Support Resources, we have a few things here. There is Post Configurator training material, best practices that you can download and have this as a reference. There's a number of different layers for common scenarios that you might encounter, as well as Post Configurator libraries. If you use Post Configurator, and Siemens comes out with new libraries. This is kind of the core post functions. You can update your existing libraries or your existing posts to the new libraries without having to recreate anything or really migrate to different versions. You can simply update your post processor, and this would be the location of where you could download these new libraries. So something noteworthy and worth checking out as time allows and is necessary for you. All right, thank you. I hope you found this session on Post Configurator beneficial. And again, if you have any questions or comments, feel free to reach out to me at any time. Thank you.